Hey everybody, hope you guys are still doing well and staying healthy. I just thought I would record a quick video to get you guys started on iLearn days 31 and 32. So kind of the theme of these iLearns and the couple ones you did before this is the relationship between different species within an ecosystem and overall what carrying capacity is. So first, let's define an ecosystem. An ecosystem is all of the biotic factors and abiotic factors within a certain area. So biotic factors are living things, those are all the different species, and abiotic factors are all of the non-living things like air, water, temperature, soil, rocks, that kind of thing. Now, within an ecosystem, we actually have a hierarchy, just like within an organism. We start at the cellular level, and then multiple cells come together to form an organism. Then from organism, the next level is a population. Now, a population is all of the organisms within of the same species within a certain area. Populations are species specific. Okay, so it's all of the organisms of the same species in an area. And then you have a community. A community in an ecosystem is all of the biotic factors. It's every different species. So this is not just one species like population. Community is all of the different species together in an ecosystem. And then finally, the last level is an ecosystem, which is a community and all of the abiotic factors coming together. So that is kind of the hierarchy within an ecosystem. Now, a big focus on this is how these different species interact with each other. And there are a couple of relationships that we can look at of how these species interact. So these are called symbiotic relationships, the first of which is mutualism. Mutualism is where both species are in a relationship and they benefit. Both benefit. Kind of the way I remember is they mutually benefit. Commensalism is a symbiotic relationship in which one species benefits and the other one is not affected. It's not harmed, it's not helped, it's not affected at all. These are kind of rare, but there is an example of that in your STEMscopedia. And then the last one is called parasitism. This is where you have an organism that benefits and one that is harmed. So you have a parasite and a host relationship there. That's like a tick burrowing into your skin to feed on your blood, or a tapeworm, or you could think of a number of different parasites. Usually the host doesn't die. It's possible that they could, but usually the host doesn't die. It's just harmed in some way, whereas the parasite would be helped. So that's that relationship there. Now, a keystone species is a species that without it, an ecosystem would completely crash. This is essential to the survival of an ecosystem. And so we really want to make sure that we're not causing those to go extinct or removing them out of an ecosystem. One great example of this that your STEMscopedia gives is coral reefs. Those are usually keystone species within aquatic ecosystems, and they are dying out around the world. So we need to make an effort to preserve those. Let's take a look at population growth really quickly. So there are two kinds of growth. There's a J curve and an S curve. The J curve is a graph of exponential growth. This is where a population is growing exponentially. Okay, so the population just keeps going up and up and up at a faster and faster rate. Now, once a population has hit its limit in an ecosystem, so the maximum number of organisms that an ecosystem can sustain, that graph will level off into what's the S-shaped curve, and that is logistic growth. And where that graph levels off, that dotted line there, is called the carrying capacity. That is the capacity or the limit at which an ecosystem can carry that species. If a population of a species exceeds its carrying capacity, usually that population will crash. It has overexceeded its resources or space, or it's out competing within the same species, and that will cause the death rate of that species to increase drastically. There are a couple things that can impact carrying capacity. One is called, well, they're both called limiting factors. So limiting factor is just something that determines the carrying capacity of an ecosystem or a population within an ecosystem. Density dependent factors are ones that depend upon the population size. So this could be like competition for resources caused by an invasive species. This could be a disease. The other one is called density independent. That is where it doesn't matter how big the population size is. If something happens, it's going to decrease the carrying capacity, like some sort of natural disaster. All right, guys, if you have any questions, feel free to email me. Good luck on these next two iLearn days. I know you're going to do great.